So, hello guys. Today I am back with another video. This time with another interesting problem. So, without any further delay, I will start this sum. As you can see, this is the problem for today's video, and this problem is in Black Book by Vikas Gupta sir and Pankaj Joshi sir, the two authors of the Black Book. And this is a pretty good problem. However, this problem is not so tough, but still, it's a pretty good problem. I'm saying once more, it's neither too easy, not too tough, somewhere in between. So today I'm going to solve this. I mean, I haven't done it before. I'm going to try. I'm definitely going to solve it. By the looks of it, it seems a bit tough, but once we simplify this fn, our job becomes easier, right? This seems a lot scary. Root everywhere. We need to first simplify it. So let's simplify f of n and one by one find f of 1, 2, 3, 4 up to f60. Then add these things and divide by 9 and see what the remainder is. So let us start. Okay, f of n is equal to 4n plus root 2 n square minus 2 over 2n square minus 1 by root over 2n plus 1 plus root over 2n minus 1. My first objective is to remove this root from the denominator and shift the entire expression into the numerator. So the best way to do so is by rationalizing. So let us rationalize. So basically we are going to rationalize. So root over 2n plus 1 minus root over 2n minus 1 by root over 2n plus 1 minus root over 2n minus 1. And basically we are rationalizing. This is the thing. After rationalizing, f of n turns out to be, let us simply multiply here, 4n into root over 2n plus 1. 4n minus 4n into root over 2n minus 1. By the way, uh, I think the denominator gives us something better. Okay, let's continue. Plus root over 4n square minus 1 that's right. Every 4n square 1 into root over 2n plus 1. Let us shift this. We don't have any space here. So this is basically f of n plus root over 4n square minus 1 into root over 2n minus 1. This will be minus, sorry. We have just multiplied in the numerator. And in the denominator, basically this is a plus b into a minus b form, which is equal to a square minus b square. Basically root over 2n plus 1 whole square, that is 2n plus 1, minus root over 2n minus 1 whole square, which is 2n that is plus 1. So you can see the denominator gets totally simplified to a mere 2. There is no n in the denominator. And now we basically need to work with the numerator of f of n. So here we can see root over 2n plus 1, and here we can simplify it a bit, right? 4n root over 2n plus 1 minus 4n root over 2n minus 1. This is um this is basically root over 2n plus 1 into 2n minus 1, right? This entire thing, right? So basically you can see root over 2n plus 1 into 2n minus 1 into root over 2n plus 1, which basically gives you root over uh, which basically gives you, no, let us not use the highlighter, it disappears quickly. So you can see, right, you can break it like this. And here is another one, root over 2n plus 1. We are everything writing everything under the root. So this is 2n plus 1 whole square, it gets outside, basically 2n plus 1 into root over 2n minus 1, right? We can do it like this. So this is coming out to be 2n plus 1 into root over 2n minus 1, and this is coming out to be root over 2n plus 1, that is 2n minus 1 into root over 2n plus 1, and being in the denominator we have got 2. Okay, now let us simplify it further. We can take root over 2n plus 1 common from these two. We are clubbing these two and these two. Okay, understood? So taking root over 2n plus 1, root over 2n plus 1 common in these two, we get 4n minus 2n minus 1 is one bracket here. Okay, give one bracket here, it will be easier. Otherwise there will be a sign mistake, which is minus 2n plus 1, and take root 2 n minus 1 common from the second and third terms. We will get, in fact, take minus root 2 n minus 1 common. Okay, so this is basically 4n minus 2n minus 1. So basically this is 2n plus 1 into 2n plus 1 minus root over 2n minus 1 into 2n minus 1 by 2. Right. Right, this is coming. Now we can do one thing. This is basically root over 2n plus 1 whole cube, and this is root over 2n minus 1 whole cube by 2. See, if we do this whole cube, it will be root over 2n plus 1 multiplied 3 times. So if we root over 2n plus 1 into root over 2n plus 1, which will be simply 2n plus 1 into, which is root over 2n plus 1 whole square into 2n plus 1 into root over 2n plus 1. So this is basically 2n plus 1 multiplied by root over 2n plus 1. Similarly, this one also, like this. Uh, I don't think we can simplify it anymore. Yes, this is the best form I can ever think of for f of n. So f of n has come out to be basically root 2 n plus 1 whole cube root over 2n minus 1 whole cube by 2. Right? F of n. Now we need to find f of 1 plus f of 2 like this up to f of 60. There's some. Let us find f of 1 to 1 by 1 and see if we can find a pattern or not. F of 1 is basically 2 into 1 plus 1 root 3 whole cube, that is basically 3 root 3 minus 2 into 1 minus 1, that is root 1 whole cube, it is simply 1 by 2. F of 2 is 2 into 2 4 plus 1 root 5 whole cube, that is 5 root 5, and this is 3 root 3. Okay, f of 3 is 23 6 plus 1 7 root 7 7 root 7 minus 23 6 minus 1 5 root 5 by 2. So you know, if 4 is my favorite number, so I'm going to do till 4. F of 4 basically 2 into 8 plus 1 9, that's a perfect square. 3 3 cube 27. Since I see that everything is of the form like this, n root n form something, I can write root 9 as 9 root 9, basically the same thing. I am just keeping root 9 as root 9 and not changing into plus 3, and this is 2 into 4 7 root 7 dot dot up to dot dot. It will continue like this. F of 5 up to f of 6 you need to find it. We need to find a pattern. Look at the pattern. Okay, if we get hold of that pattern, then we can find f of 6 in that manner. and calculate the entire sum, I think everything will either it will come in the form of sequence something like AP or GP, or everything will get deducted. I think that's my gut feeling. But let's first find that pattern we are looking for. See everything. So let us write 1 as 1 root 1 for the sake of simplicity, for so that our task becomes easier, right? Okay. Basically, you can see if we put the input as 1, the first term that is coming in the numerator has 3, right? Basically 1 plus 2 is equal to 3 here. Case of 2 we have got 5. 2 plus 3 is 5. Basically 3 here I've got 3 plus 4 is equal to 7, and 4 we have got 9. So basically 4 plus 5 is equal to 9. This is my first approach. 1 plus 2. So 1 plus 1 plus 1. Basically we can write it like this. If we consider 1 as k, right? K, and 2 as k plus 1. So basically sum of k and its next number k plus 1. In case of 2, f of 2, k, in this case k is equal to 2 plus k plus 1, which is 3. So again sum of 2 and its next number, which is 3. It goes on like this. 4 plus 5 next number, 3 plus 4 consecutive number sum gives you the first number which you can see in the first term of the numerator of the output of f of n, right? It goes on like this. F of 5 will get 5 plus 6, so first number here will be 11. Say we need to find f of 5. We don't know what f of 5 is, but we are completely sure that the first term will be 11 root 11 something, because 5 we need to add the next number which comes after 5 to 5 to give this thing. So next number which comes after 5 is 6. So 5 plus 6 gives 11, right? 2, and every denominator is 2. So we have found out the first term of the numerator. So we have found out the first term of the numerator, and now we need to find the next term of the numerator. It is basically, this thing is 2 less than 5 minus 2 is 3. Basically it is 2 less than this number. Okay, I hope you can understand. So basically the form is like this. Put in input f of k is equal to uh, k plus 1 root over, it will, there is a little space, let me write here. The general form is, let k be any number starting from 1. K belongs to natural number. Okay, f of k is equal to basically k plus 1 into root over k plus 1 minus uh, k plus 1 2k plus 1 minus 2. That is basically k plus 1 minus 2. That k plus 1 minus 2. into root over k plus 1 minus 2, like this, by 2. This is the general form. If we simplify it a little more, we get f of k, basically 2k plus 1 into root over 2k plus 1 minus 2k minus 1 into root over 2k minus 1 by 2. This is the general form. K belongs to any natural number starting from 1 to infinity. This is the general form we have found out. And what do we say? Our job is done. General form of consider another number k. You can also consider as n. You can also consider another number. Consider it as n. There's no problem. Basically, this thing. Ultimately, we have come to this thing only, right? We have come to this thing only. Basically, there is no point in finding the general form. I just wanted to do some back calculations. Otherwise, you want to do some back calculations, something like this. So we have got this form. So let us put f of 60 here. F of 60 is equal to basically 60 plus 61, that is 121 root over 121 119 root over 119 by 2. We have found each and every term, I mean all the terms that we need. Just we need to find the sum. Now let us find the sum. F of 1 plus f of 2 plus f of 3 plus f of 4 plus dot 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 plus up to f of 60 we have got. This will be basically equal to f of 1 is we have found it to be root 3 minus 1 root 1. Let us minus 1 root 1 plus f of 2 is basically 5 root 5 minus 3 root 3 plus 7 root 7 minus 5 root 5 plus dot 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 plus here we have got 121 root 121 minus 119. Again, this is not holding in this space. Right, same by 2. As you can see, this 3 root 3 get cancelled. 5 root 5 cuts, 5 root 5, 7 root 7 cut, like this. Everything in between will get cancelled. uh, every fourth function every fourth function every fourth function, the last term will get cancelled. Only the first term of the numerator of the fourth function will remain. So if we, in this case, if we add f of 1 plus f of 2 plus f of 3 plus f of 4, see, everything will cut, remain except for minus 1 root 1 plus 9 root 9, right? So we can break this entire sum into 15 four root functions part. Suppose this is one group, f of 5 to f of 8 is another group. It will continue like this and end with f of 57 to f of 60 being the last group, right? So when we do f of 57 to f of 60, only the again, as I said, the fourth functions first, the fourth function's numerator's first term will remain. That means basically in the numerator of this entire sum we have got just minus 1 root 1, and this will also get cancelled. Like the previous one is basically 119 root 119 minus 117 root 117. So 119 this thing gets cancelled, just will remain 121 root 121 by 2. Root 121 is basically 11, and this is again 11 square. Basically this is 11 cube minus 1 by 2. Simple. 11 cube is equal to 1331. I remember the cube up to, I think, currently 12. I used to remember up to 16 something. Yes. 11 cube 1331, 12 cube 1728. This is minus 1 by 2. This is 1330, right? By 2. This is 665. This entire sum is coming out to be just 665, 665. So we need to find the remainder when this sum is divided by 9. So 665, going to find the remainder, uh, the remainder comes out to be, I think, this is what, 9 7 is 63, 35, 9 3 is 27, 35, 35 minus 27 is basically 8. So you can see the remainder is 8. So 665 congruent to 8 mod 9. This is the remainder. Remainder is equal to 8. This is the answer. Wait. This stylus, it is not working properly. So this is basically my new sign. So as you guys can see, the remainder of this sum when divided by 9 is basically 8. Answer will be 8. See, this is a black book sum and we just solved it within 30 minutes. I had to explain to you guys, otherwise I could have solved it within 10 minutes at most. 10 minutes at most I could have solved it. Not so tough. You just need to simplify this thing. This part is basically not required. You just need to catch the thing, catch the pattern, what's happening basically. Your job's done. Or simply you can put a value of 60 as you wish, but I just like to do it in a mathematical way for the sake of doing mathematics. Basically this is it. Bye guys. See you again. Signing off.